Welcome, everybody. Thank you for being here today. I'm Lena, part of the ventures team here at Startup Autobahn by Plug and Play. And I'm super excited to be here with Joachim Kaiser from Porsche and Daniel Halbig from Spread, who've worked on a great collaboration. And I'm sure they can't wait to tell you more about it, tell you what they did, and then share their news. So I will hand it over to Daniel right away. And if you have any questions, obviously feel free to post them in the chat and we will answer them later on.
Thank you, Alina. And and keep me updated if there's any questions. I will switch now back to the presentation mode. And thank you very much, everybody. Welcome to our breakout session. We are really excited to talk about what we did during the Startup Autobahn pilot we did together with Porsche. It's all about Next Level Aftersales Twin, linking the CAD model with the metadata and the workshop media to create a new product understanding in the after sales. And I'd like to introduce to you Joachim. Joachim, maybe you can say something real short about yourself.
Thanks, Daniel. Great to see you all, or not to see you all. Very excited to be here today and to show you our use case and pilot that we're doing with Spread here. I've been working in the after-sales department for about 10 years now with Porsche. And before that, I was in consulting, also working in the automotive sector. So yeah, very welcome. And I hand it over to Daniel.
Thank you, Joachim. So yeah, to myself, I'm a co-founder and CEO of Spread. To my background was last 10 years in the automotive as well as in the machinery industry. Got a deep dive along the processes and saw the potential in digitalizing product information and also the experience of engineers. And that's where we come next to the topic of digital twin. So for the audience, we have a little poll that Alina will start in a minute, and it's all about the digital twin. So we would like to know from you, what's the maturity level of the digital twin at your company? You have multiple choices that you can define and select in the poll. And Joachim and I will talk later more about the results and have a little discussion also possible where you could ask us questions about all what we did and what's the next steps in our partnership. All right, so what we will talk about is just so that you can relate to what is actually workshop media, what's the challenge there. Working with the CAD model of a car, what is basically also the challenge in creating such a workshop media. Then we will have a deep dive also into the workshop media strategy of Porsche for the 2025. Then we will shortly introduce our use case, show you what we did there, have a little video presentation also prepared there, where you see on an actual Porsche model what we did with in regards to the CAD model and the product information. And then we will have a talk also about what will be next steps, how can we embed and really create a product understanding in after-sales twin. So as of next, I will hand over to Joachim, and Joachim will tell us more about the challenges at Porsche in the workshop and also in the after-sales department.
Thank you, Daniel. Maybe Alina, I don't know, do you want to say one or two sentences about the poll that we have?
Just that it's live. We have a couple votes already, but there's more that can answer that question, I think.
Okay, everybody, so just go to
so you find it in the chat.
Yeah, find it in the chat section. There's this Umfrage or poll, and just answer the question. Thank you.
All right.
Okay, Daniel, okay. All of you that work in the automotive sector know that cars are complex things, and they're getting even more complex, especially with new technologies like charging, like connected services, like autonomous driving. All these new technologies bring a new kind of complexity to the workshops. So now we're facing the situation more and more that the cars are part a virtual product. Yeah, like you can see, you have a lot of functions in the car. You have software modules in the car. You have a ton of signals in the car, and these numbers are increasing. Plus, of course, still you have all the hardware components, all the electronic control units, sensors, actors, and all stuff, and a lot of communication buses in the car. So what we are facing in after sales in our department, we're creating the repair manuals for the workshops around the world. So with each new model that is going to market, we write about plus 1,000 repair manuals, meaning more than 2,000 new chapters with such as 16,000 subchapters with lots and lots of illustrations, like 25 to 30,000 illustrations within these repair manuals. So I guess you can imagine how much work it is to create all these repair information for the workshops. So how does the process work at Porsche? What we do, obviously, we have a lot of preparation and planning, where we plan on which repair manuals and repair information are actually created for a new model. Then we set up the basic structure of everything, try to find out, okay, what is really new about the car, what are changes to other cars, what can we take over from previous car models, what has to be deleted, has to be overdone, and so on. So, and after this clarification phase is done, we actually start into the creation of the repair media. And this takes about 24, sometimes more weeks for a repair manual to create. Of course, not that's just the duration, it's not a work effort. But we will come to this later, that you can see how our editors and authors just take a lot of time in finding the right information to put into the repair manuals. On the right-hand side, you can just see a little example of how a repair manual looks. We usually have as few text as possible, just the steps to take the technician through, and a lot of images that help the technician to really have a good picture of what is actually on focus right now in the repair manual. So how do we do the editing or the authoring of the information? Our authors go through several tools. We do have a lot of tools. Everything is digitalized, of course. Nothing happens really on paper anymore, but it's just a lot of unconnected tools, such as 3D viewing, CAD model tools that help us create the pictures. We have a lot of information in PDF, PowerPoint, Excel files, whatever comes from our engineering department, research and development. And then, of course, we do have a lot of expert knowledge that goes into the repair manuals, a lot of really experienced colleagues there. And plus also the knowledge that comes from earlier cars. So all this makes it really difficult and takes a long time to get everything together and put it in the right repair manuals, in the right repair steps. Yeah, as I mentioned before, actually the creation of the media is almost the least time that goes into it. Yeah, it takes about 20% of an editor's or author's time to just search for the right product information, to get everything together on a new part, a new function, a new repair method of the car. They spend lots and lots of time in meetings just to consolidate on how the repair method is working, how the new part is looking, all the model, all different models that are related to. So, as you can see here, it's actually only 20% that go in the real creation of the media. So we're facing, like mentioned before, more and more product complexity. So, and this will even increase, and the current tools and solutions just do not provide with a lot of understanding on how to automate and automate all these processes. We have a lot of digital information, but we're just not having the right tools and the right processes to extract this digital knowledge from the tools and models. Also, we have a lot of data, a lot of bits and pieces there that are somehow related, but nobody really has the overview of how it's related, how it's connected. And yeah, with all, like I mentioned before, autonomous driving, connectivity, and also other new digital services coming to the cars, it gets even more and more complex. And then one other last thing we're facing is that, yeah, like the heading says, product lifecycle management is not just engineering. Sometimes in after sales, we have the feeling engineering just stops with the start of production of the car, but no, it doesn't. Cars live on, and especially if you look at the Porsche, we give a long lifetime support for our cars in the workshop. So it's not just ending after 10 years, we support our cars over 10, 20, 30, even 50 years. So this also takes a lot of effort to go into the repair information. So what did we do to face these challenges? We set up a media strategy 2025 plus to face the future challenges. Our vision is to create or provide intelligent media for a smart and connected workshop. So this is where the first, the very basic step is to have efficient editing. To have a data-driven creation of the media, which has to be more and more automated and connected. So in our vision, the editor or author just actually approves what the machine or artificial intelligence suggests him to do. This should, bless you. We're also aiming to an on-demand repair route. So right now, the technician in the workshop has the challenge to put together all the single repair manuals that he needs for his repair. And we want to provide him with a dynamic repair sequence, really optimized and fit for his car that is right in front of him right now, and the state of damage or problem that he is facing and the tools he has available in his workshop. So for that, we need intuitive media. Meaning that, like I mentioned before, the repair assistance has to depend on the situation. We have to move away from a static repair manual to an adaptive and intelligent repair. And all this is only possible for us if we have a perfect digital twin that we can already use for editing. And also we want to provide that digital twin to the technician in the workshop, so that he has a digital, perfect, unique digital image of the car that he's facing. With this, I hand over to Daniel. Let me just say we started a pilot study last year already and are going to finalize it this year together with Spread. They're a really great partner with this. And Daniel will tell you more on how we proceeded and how they did it.
Thank you so much, Joachim. It's a pleasure working with you. So, what are we doing and what are we utilizing in order to abstract this digital twin? Basically, we start with an already constructed model. So we take the CAD model and abstract all the information from the CAD model, including geometry, metadata, which is also included in the CAD model, and write it in our own product information model. This product information model is way more compromised than the initial CAD model. So for example, we have the Mercedes S-Class or the Porsche, for example, which is 2.7 gigabytes large. And in our model, it's just 177 megabytes. That enables us to further enrich it quite easily, analyze it really fast, as well as create new product informations based on this product information model. This helps us change how processes are conducted and really create a product understanding. And what do I mean with that? The initial beginning phase of the digitalization was gathering information. And this was quite efficient, but with all the information, you have just information there, you have just data, just raw data, which is not really linked to each other. So based on that, you have to create a product understanding. And to really achieve that in a digital manner, you have to have the possibility to connect information and data to each other. That's what we utilize in our spread information model, as I previously stated. So this helps us easily analyze, guide through the product, and thereby create that product understanding in the system by itself, so that a system can make a proposition on how to repair, for example, or analyze the product by itself. And that's what we do as second part. We focus on really high value use cases of our customers and create really that new understanding with a high value impact for our customers. And the third part is what's really important for us to spread that knowledge, to democratize that knowledge to other departments. It's also necessary to have the possibility to visualize it very easily and in an intuitive manner that everybody can understand it, that everybody can, when he looks at the model, understand the information it is given. So to initiate our use case and tell you more about the use case we did with Porsche at the startup Autobahn, it's called intelligent filtering of neighboring parts. For the repair manuals, it's very important to identify the connection and the direct link of parts to each other. So for example, an editor or a technical editor in the after sales needs to know how, for example, a part is connected to other parts, with which kind of fasteners, which kind of material, so that he can thereby create that manual that you just saw, step by step, really saying, hey, you first have to take out this screw and in order to take off the other parts. And with our neighboring parts, we are able to identify and visualize all neighboring parts, so directly connected, as well as further connected, so second level or third level connection of parts. With that alone, it's good to understand the context of the car and of the parts to each other. But we also were able, with our classification, to really identify fasteners, for example, in this case, and thereby also label additional information to each part that is classified, giving new information on a high level available per click. This possibility and this use case alone creates great value for our customer Porsche, because it reduces the time to search for these information bits of up to 50%, helping technicians achieve their creation of that repair manual in lesser time. And as I mentioned here, just to give you an overview of those 3 dimensions. First, the classification. As you can see here on the picture, we're able to classify all fastener parts, for example, here in this case, and thereby having this visualizing available. Then there's the neighboring parts, giving context and connectivity to each part, which is connected to other parts, and also the possibility to filter and search for information basically by a drop down, giving really great access to the engineers, really basic selecting of that information pool. Oops. Sorry. Normally there should have started a video. Oh yeah, there you go. And here you can see our functionality live. So as you can see here, I'm selecting the front of this Porsche, and then start the neighboring parts. As you can see, the results are available right away with no time delay, and you see all parts which are connected on first level, second level, or third level to the selected part, giving the possibility to also engage in the filtering or in the detailed information search. So as I click just, for example, here, the connecting elements, you can see on the second and third level, for example, as well, that parts, that these connecting elements, fasteners in this case, change and giving the results right back. And as you can see here on the first level, for example, we have 2 times a Schnappmutterklemme, which is a German expression, and also other screws, for example, and parts which are connected on this level as well. So with Porsche Together, we have defined 3 levels of bringing product intelligence and creating this digital after-sales twin. And from our perspective, it all starts with a foundation. So by enriching the model with additional information, connecting the relations of parts and information to each other, and thereby have a comprehensive analysis and search possibilities very quickly and intuitively for the technician to guide through the model and have all his information on the model, and not search in Excel files or in PDF files. Taking this information and enriching this CAD model. Second level is the semi-automation. Basically giving, based on the first level of information, repair suggestions, disassembly sequences, so that, for example, a technician, as Joachim talked about it, doesn't have to imagine or visualize for himself what steps to take in order to repair this part or the product, but rather to really have that step-by-step enabled by the system, which can then be very intuitively manipulated, and also with additional information enrichment, like working time, like tools that are required, or service calculations, and enabling this to be viewed in any kind of media, so that you don't have to create those pictures you saw, those illustrations that Joachim shared, giving a new engagement with the product for every workshop, either through different medias or through the interactive model itself. The third level is the fully automated. And basically the technician takes on another role. He's more checking, he's more evaluating what the system provides, what the suggestion of the system is, and basically it's close to perfect, as he can just validate. And every information is enabled, giving those informations in real time and making it available for validation as soon as the model is created. And also creating and automizing this visualization of the repair steps for the workshop media. So that, for example, a workshop technician with a defect car can access this media in real time, edit it as well, and enable a new understanding. So, as mentioned, we want to come from machine follows human to more a human follows machine approach, where we enable a product enrichment, have that semi-automation as a next step, and then really create that digital after-sales twin, where you really engage with the system, having that understanding of each and every product. So this is it for us, for our presentation. I hope you enjoyed it. And we will now come to the results of the question we presented in the beginning. And we're looking forward to your answers, and also want to engage with you, and are available for questions and follow-ups. So really looking forward to what you want to know more about our case or our initiative. Thank you very much.
Great. Thank you, Daniel. Thank you, Joachim. Regarding the poll, we are at 62.5% for number one. So we have to find a strategy in some department.
Cool. Yeah, that's probably most.
Is that what you expected?
No, it is. It is something where we see, it gets more important. So the strategy is thereby something of a key, but it's very early in that stage. The next phase is to gather all those information points and possibilities in order to really engage with that information pool. So
I was actually hoping for someone to hit the 5, but there we go.
So we would have gone to him, probably. We would have asked for more information.
Someone just hit it. Someone just put in the 5.
All right, identify yourself, whoever hit the 5. There's a couple of questions from the audience. I'm just going to pass them on to you. So in case you need to create a 3D animated step-by-step procedure, such as assembly, disassembly guide, so there's no need for any third-party tech doc editor.
Well, that is our path forward. So basically enabling the step-by-step manual creation from different angles, optimize also the angles, and with a suggestion which is presented for the engineer or the technician. Sure, it will be something that he can really easily and intuitively manipulate or engage with. So it will not be the 100% version, but we are working towards that this will be something where the creation of this media, like for example, we had a case where it took them almost 2 days to create it just for one possible sequence, for one repair sequence. And we're working towards that this is the something out of the past, yeah.
Still, honestly, right now we are also in parallel building up a new editorial system at Porsche, and it's still going to be a challenge to connect the spread solution with our editorial system. So we'll still have a question. Okay, sorry.
Okay. Oh, keep going.
Yeah.
We have another question. So is the usage data mentioned on slide 12 derived from statistical field data? And how do you integrate load and damage information from real usage of this vehicle's components into the repair journeys?
Yeah, well, that will be something in the future for sure. It's not something that is currently on track where we have a direct answer for that. But for sure, we are envisioning that that this will be part of a solution to integrate such a visualization and that's such a status. Yeah.
Very good question, though. Let me say that in our vision of the future workshop, we have actually already had a pilot too with camera systems that the car just drives through, or also in combination with the diagnosis information, of course, so that you can identify automatically what is damaged within the car. Also, we're looking at if you think of an accident that the car maybe had, you will always still have the what's it called, the Gutachten. Someone help me. Yeah, that someone looked at the car in advance, and you have all the defective parts listed up, and how we assessment. Thank you. And how we can introduce all that within the system. Yeah, but still a way to go.
All right, there's more questions in the Q&A section. So what are the next steps planned?
Well, first, yeah, okay.
I was straight shooting always, so please, Joachim, go ahead.
Sorry, Daniel. Yeah, well, first of all, we're still in this study, which is looking really well. So we now have a web-based solution that is working quite well. We still have to handle a lot of stuff with the incoming data from our R&D department. CAD-Data is still not always 100% the way we wish it would be. So that is one thing we have to handle. At this point, Daniel mentioned it at one point, is that we just took the fasteners to classify as one part now. Further steps would be to look at an automated classification of all parts, so that you can select fasteners, can select body chassis parts, can select, I don't know, you name it. So the classification of the part will be essential. And then, like I mentioned, one next step would be on how to integrate this into our editorial system. And with our
Great, thank you.
list of materials, sorry.
Daniel, anything to add from your side?
I said is exactly what we're planning. Next steps, classification of additional parts, mapping it to other parts, really mapping also the structure of and the logic behind the after sales of Porsche to the model, optimizing that, and thereby creating new value to be added, so we can add automatically new information to this given structure.
Mm-hmm. Is this digital twin different from a customer-facing, sales-oriented model or digital twin?
Joachim?
Good question.
Or should I?
You can try. The question is, how does a customer-oriented, sales-oriented model look like? I think it probably is. You can continue, Daniel. But since it's way more technical, I mean, we have every single part of the car in there. We have every single ECU, data bus, everything in there. So that's probably quite different from a customer view.
Yeah, and to add, like the customer-oriented digital twin would be also including performance issues on site of that one specific model. And we are currently working more on a holistic level of possibility variances of those cars, but not on a customer-specific model. So we don't validate this on each product that is out there running and driving on the streets. So this will also include performance topics, but we are focusing more on the engineering and CAD-based information given along the whole value chain. So that's what we are creating now.
Great. And to what extent will Spread become a PLM system?
We see ourselves more as the product intelligence platform. So differentiating to a PLM system. PLM systems also create and construct design products. We set on those PLM systems utilizing this information to spread and enrich by analyzing the 3D data to other departments on a more easy and intuitive way. Could be on an iPad or could be on our apps, and thereby create value and product understanding really in the whole company. So that's the point where we see ourselves different to a PLM software.
Thank you very much for the clarification. Maybe one point that could be interesting is, I mean, you know, you see a startup, you really like the technology and think it's cool, but like, how do you get started? You guys are now the experts on kind of making it happen. So maybe you can share some best practices you've gained.
Yeah, from our perspective, the validation really early with our customers were something very important for us. Really getting fast feedback loops, getting engaged with them right away after our start was something that really helped us find the path towards our solution. And yeah, keep grinding and really engaged with the problems of our customers, and thereby creating value is something. Really understanding the customer and the user by himself is something very to be focused on.
Anything from the corporate perspective, Joachim?
What can I say? Just we're actually looking for quite a time for different solutions, and there wasn't a lot to find. So we just got in contact with Spread, and they were really helping, really straightforward. And I like the contact there, like Daniel just said, really agile. You just put in your user stories, and after 2 or 4 weeks, you just get the results. So yeah, it was great to work with, or is great to work with.
Fantastic project and collaboration. There's one follow-up question on the PLM system one we had earlier. So is it more than a UX? And if so, how is WebAssembly on your roadmap?
What is? Can you further deepen? So WebAssembly, do you mean the visualization of the CAD in web, or what do you mean by WebAssembly?
I assume it's really more into the construction part, or more of the how to build it up part. I assume, but I don't know.
So,
because
yeah,
right now we're really focusing on disassembling the car.
So, if I understand it, our solution is web-based, a web-based solution that can be basically enabled on each device. You can just type in the address, and it is enabled on cloud, on a server, or even on a local PC. Right, so it's already web-based, if that's answering the question.
Let's see.
Yeah,
maybe there's more clarification coming in.
maybe Ivan can just get in contact with Daniel afterwards.
Mm-hmm.
Sure, I'm always available.
Yeah, what would be the best way to contact you guys? Through us, or do you want to share your details? Like, what's the easiest for you?
You can share it. Yeah, it's no problem. We had it on the slides anyway. So
yeah, and as mentioned here are our contacts. So get engaged with us if you have any questions.
You can contact Daniel on his phone number.
Yeah.
50 calls later.
No worries.
We got about 5 minutes left. If there's no more questions from the audience, it seems, here's the contact details. Otherwise, feel free to contact us or check out the profiles through our Expo website. And yeah, thank you very much for joining the session today. Very interesting questions. Thank you, Joachim and Daniel, for sharing your insights. I think it's a great collaboration, and we look forward to seeing where it's going next. And with that, happy Expo. I hope there's plenty more interesting sessions coming up. And yeah, speak to you soon.
Thank you, Ali.
Thank you all. Have a great day.
Thank you very much,
enjoy
guys.
The rest of. Oh, and by the way, we have another breakout session at 4 o'clock together. Philip Noll, my co-founder, and is talking with Mercedes-Benz on the whole topic of electronic communication and wiring. So it's really a very interesting topic. Feel free to join at 4 o'clock, Philip Noll from SPET with Mercedes-Benz.
And there's a couple more Porsche sessions also, if you're interested in that. One on with delicious data on food waste, and another one with the project partner and XRT for the use of mixed reality solutions in vehicle sales. So lots of exciting topics. If you want to meet Daniel or his colleague again, tune in at 4. And for everything else, feel free to check out the schedule or the website, and speak soon. Bye, everyone.
Thanks.
Thank you. Bye-bye.